In this video, we'll be trying to solve a physics test question on dimensional analysis. The question here says, the frequency f of a stretched string depends upon the length L of the string, the tension T in the string, and the mass per unit length mu of the string. Establish the relationship for the frequency using the concept of dimensional analysis. All right, so that's the question here. So how do you solve this question? So solution to this question, solution. So let's get this down. Solution. Don't forget that we've already treated the concept of dimensions and dimensional analysis in our previous class. I'll leave a link to our first class on dimension and dimensional analysis in the video description. Okay, so the first thing we're given here is the frequency of the stress string. Right, so first things first, we'll list out given parameters. So given number one, we're given the frequency. So first thing we're given there is frequency, and that's a small f. Our next task would be to write out the dimension of frequency. Record that frequency is equal to 1 all over period, that's time, and that's equal to t to the power minus 1. So when it comes to frequency, the dimension is t to the power minus 1. So I'll write down there. So f is equal to t to the power minus 1. This being the dimension of the frequency. Next up, we say the next thing here is that depends upon the length L of the string. Number two, we're given length that's L as being equal to the dimension for length is a capital L, that's this, right? And then next up, again, they said the tension T in the string. So the third thing we are given there is tension in the string. So tension, they call tension capital T. Let's get the dimension for tension. Now, what's tension? Tension is actually the force that exists in a stretched string or rope. Okay, so in essence, tension is simply the force that exists in a stretched string. So therefore, we can say that tension has the same dimension as force. And for force, the dimension of force is actually equal to mLt to the power minus 2. Again, as I said, we've treated the concept of dimensioning in our previous class. If you missed that class, I'll leave a link to check out the class on dimensioning in the video description. So check video description for the link to see how we dimension parameters. The last thing we're given that they said, and the mass per unit length mu. Right? I'm giving mass per unit length, mass per unit length. They call it mu. Now, mu is simply equal to, they said, if you're having mass per unit length, it's actually self-explanatory. So it's simply equal to simply mass all over length. That's what is called mass per unit length. Mass is actually capital M in dimensioning, all over length is capital L. This becomes mL to the power minus 1. So in essence, the dimension for mass per unit length is mL to the power minus 1. So this becomes mL to the power minus 1. Alright, so here's your first task. List out the parameters and of course their dimensions, which we've done here. The second task when it comes to dimensional analysis is to look out for the parameters that orders depend on. Right, or the particular parameter that depend on the other parameters. Looking at this question here, it says that the frequency of a stress string, they said this one here, depends upon. So it is frequency that is depending on the other parameter. Now that particular parameter that depends on other parameter, we'll take it out here. So it becomes frequency, small f, all right, depending. To show depending in mathematical form, we use directly proportional. All right, we use proportionality. So directly proportional to, they said, depends on the length. So L, we use a dot. Also depends on tension, we have T. Also use a dot. Also depends on mass per unit length, which is what there, mu. So we have this. All right, so now have LT mu. We have this. Now our next task for here our next task here would be to impute the superscripts x, y, and z. So we can say f is directly proportional to, for L, small l, for L we'll put x dot, T we'll put y dot, mu we'll put z. So basically this is how we do dimensional analysis. Okay, so the next thing here is that I want to change my proportionality sign to equal to, and that means we'll have f is equal to, I'll have to introduce a constant. All right, so if you want to take off a proportionality sign, you put an equal to and put a constant. The constant we'll use here is k. All right, so I'll replace this one here by equal to and k, and then I'll bring back this one here. Okay, so equal to and k, then bring back the L to power x dot, T to power y dot, mu to power z. So we have this. All right, at this point here, your next task will be, we'll assume, right, assume that k is equal to 1. Right, if k is 1, what does it mean? This becomes f is equal to, so it becomes 1, which is k, into L to power x dot, T to power y dot, mu to power z, and anything multiplied by 1 is that same thing. So this is equal to L to power x dot, T to power y dot, mu to power z. So we have this. So in essence, we're left with frequency f being equal to L to power x dot, T to power y dot, mu to power z. So the concept of assuming k being equal to 1 is just to temporarily eliminate k. Right, when we are done with our solving, we'll bring back the value of k. All right, so let's proceed with this. At this point, let's substitute dimensions. Substituting dimensions. What do we have? For f, frequency, if you go back to the dimension, we said f is equal to t to power minus 1. So f here becomes t to power minus 1. F is equal to, next up we have L. L, we got the dimension as a capital L. So this raised to power x dot. Next up we have t. All right, for t, tension, we got the dimension as, I'll put this in brackets since there are plenty, mlt to power minus 2. This y, okay, so this was the dimension for t, right? mlt to the power minus 2, and then the last one there's mu dot, next in there's mu to power y, and we got mu as, the value for mu is ml to power minus 1, mass per unit length raised to power z. So we have this. All right, so we are now at this point after substituting the value of the dimensions. Let's now expand this. If we expand this, we have t to power minus 1 is equal to this L to power x, L to power x dot, for the m. All right, so use y to multiply each of the terms in these brackets, all right, as their superscript. So it becomes dot, the first one I have there's m into y multiplies the 1 here, is a 1 here. So y times 1 gives you y. We'll take L2. So y times the 1 here. So y times 1 gives you y. We'll now take t, becomes y times the power here, which is minus 2. Y times minus 2 gives you minus 2y. So we have this. All right, coming to this 2, we repeat the same thing here. So z times the 1 here. So it becomes m into z times 1 is z. Then L into z times minus 1. Z times minus 1 is minus z. So L into minus z. So we have this. All right, so we are now at this point here. Next we'll do here, when it comes to dimensioning, this is called the MLT dimensioning system. All right, by MLT we mean we arrange our dimension in terms of mass, and then length, and then time. All right, so from here at the left hand side of the equation we have only time. So I won't stress with this. I'll just come here, repeat t to the power minus 1 as equal to, on the left hand side we have a lot of terms. I'll take the m's first. The first thing I have there is this one here, which is m to the power y multiplied by this one here, which is m to the power z. So I'm done with the m's. Let's take the L. So it's called an MLT. After the m's, take the L's. So dot, I'll take the L. The first L on the right hand side is this one here, which is L raised to the power x dot. I still have another L here, which is this one here, L to the power y. So dot L to the power y. I still have another L again, this one here, which is L to the power minus z. So L to the power minus z. So I'm done with the L. Let's take the t's. For t's, I have just this one here, which is t to the power minus 2y. Alright, so I've now arranged this in terms of MLT. You can add here rearranging if you want to. Rearranging. This still works too. Alright, so this becomes t to the power minus 1 is equal to, recall that from the concept of indices, if I have two same base, a times a multiplying, such that the power of one is m and the power of the other one is n, this will be equal to a into, if two same base are multiplying, simply write that base, then add up their power. So it becomes m plus n. Alright, so if I have the same base multiplying, simply add up their power. That's the concept. So from here, m and m are multiplying, so it becomes m into, add up their power, y plus z. So I have that. That becomes y plus z. I'm done with L. M. I'm going to L. 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 They're multiplying. I'll add up their power. So it becomes x plus y, y plus minus z. And that becomes x plus y minus z. X plus y minus z. That's L. Let's take t. For t there, what do we have there? The power of t here is minus 2y. So we have this. Alright, so basically we now have the MLT system here. At this point, what we'll have to do here is we'll compare pairs. So we'll come to this point and put in comparing pairs. Okay, let's start with the m. For m, looking at the left hand side, you can see that there is no m on the left hand side of the equation. So we'll call that 0 is equal to, looking at the right hand side of the equation, you can see that for m here, the power is y plus z. So you can say 0 is equal to y plus z. Call this your first equation. Let's take for L. For L, what do I have? Looking at the left hand side again, observe that there's no L on the left hand side of the equation. Again, we write 0 is equal to, for L on the right hand side of the equation, the power is, so the power there is x plus y minus z. That becomes x plus y minus z. Call this equation 2. And then finally for t, so for t, again, looking at the left hand side, you can see that for t here, there's a term for t on the left hand side, and the power there is minus 1. So we have that for t, you have minus 1, so minus 1, it's equal to, for the right hand side, for t, you have the power as minus 2y. So minus 1, it's equal to minus 2y. Call this equation 3. So you have this. Alright, so our task will now be to get the value of x, y, and z from any of these equations. Looking at this, we can see that the easiest to solve here would be equation 3. From equation 3, we have that minus 1 is equal to minus 2y. To get y, I'll divide here by minus 2, divide here by minus 2, minus cancels minus, 2 cancels 2, minus cancels minus. You can see that y is equal to 1 over 2. You can see that here. Alright, y is 1 over 2. We've gotten the value of y. We can put y into equation 1 to get the value of z. Okay, since we have only y and z, putting y into 1, so put y into 1, put y into equation 1, you have that 0 you have that 0 is equal to y plus z. You have that 0 is equal to y plus z. And to get the value of z, all we have to do here is move y over here. Alright. So move y becomes minus y is equal to z. But we said y is equal to 1 over 2. But y is equal to 1 over 2. So we have that minus y, 1 over 2 is equal to z. Alright, so we've gotten y as 1 over 2. We've gotten z as minus 1 over 2. Let's now get the value of x. So I'll put the value of x, or I'll put the value of y and z into equation 2. So put y and z into equation 2. From equation 2, I have that 0 is equal to, so 0 is equal to x plus y minus z. Impute values, we have that 0 is equal to x plus y is 1 over 2 minus z. Z is minus 1 over 2. Right, imputing values here, we have that 0 is equal to x plus 1 over 2 minus minus here gives you plus, that becomes plus 1 over 2 plus 1 over 2. If I proceed to solve this, we'll have that 0. So I'll be having this as 0. Let me read this line here. I'll be having this as 0 is equal to x. Alright, you have half plus half, that gives you 1, so it becomes plus 1. To get x, I'll move this one over here, that becomes a minus 1. So I have that minus 1 is equal to x. So therefore, we can say that x is equal to minus 1, y is equal to 1 over 2, and z is equal to minus 1 over 2. Alright, so we have this. So we've gotten the value of x, y, and z. What do we do next? We'll substitute this value of x, y, and z into this particular equation here. Let's see. Alright, let's look at this equation here. Let's call this equation asterisk. So I'll call this asterisk. Okay. So substituting into equation asterisk, let's substitute those values. Okay, let's see this. Alright, so substitute x and y, x, y, z into asterisk. Okay, so substitute x, y, and z into equation asterisk. Would have that f, right? It's equal to k into the first thing we had that was L to power x. The value of x was minus 1 dot t into power y. The value of y is 1 over 2 dot mu to power z. The value of z is minus 1 over 2. So we have these values there. Alright, so I'll try to simplify this. We'll have that f is equal to k. Now, when you have L to power minus 1, that's equal to 1 all over L. So you have this dot. When you have t to power 1 over 2, when something is raised to power 1 over 2, it means the square root of that thing. So it becomes the square root of t dot. For mu, observe that mu has a negative. So having this negative means you have to take inverse. So it becomes 1 all over. Now this inverse removes the negative, but I'm still left with 1 over 2. So 1 all over mu to power 1 over 2, that becomes the square root of mass per unit length mu. So we have this. Okay, multiplying this, what do we have there? From here, this will be equal to, okay, so this will be equal to, I have k dot 1 all over L, k dot 1 over L dot, next thing I have this root t times 1, that's root t. So that becomes root t over root mu. That becomes root t all over root mass per unit length mu. Okay, continuing with this. Now, in mathematics, if I have root a all over root b, since we have square roots for both numerator and denominator, we can put both of them in the same square root and have a over b. This is mathematically correct. All right. What does that mean? That means we can put both t and mass per unit length under the same square root sign. So what do we have here? We'll have that f. We'll have that f is equal to k. Of course, first things first, we have k times 1. That gives you k. So it becomes k all over L multiplied by, in the same square root sign, so root square root of, the next thing we have there is, we said we can put t and mu under the same square root sign, so it becomes t over mu. For our final simplification, we now have that f, the frequency, is equal to k over L multiplied by t all over mu. So basically, this becomes the relationship between them, and this is the answer to that question. Okay, don't forget that I said I'll leave a link to our first class on dimension as well as dimensional analysis in the video description. Okay, all right guys, so don't forget that you can check out my website to get my course. Simply visit www.junaemmanuel.com/courses, or you can get my books, my scholarship books, and other available books on my website. Simply visit www.junaemmanuel.com/books. You can also join my channel membership to get access to exclusive contents for just channel members. I'll leave a link to my channel membership in the video description. All right guys, so if you enjoyed this video as usual, do well to hit the like button. Like this video, leave a comment. For your comment, if you enjoyed this video, tell us you enjoyed this video in the comment section. Also, if it's your first time here or you're yet to subscribe, please do well to hit the subscribe button, hit the bell icon and select all so that you get notified whenever we upload a new content. And then finally, do well to share this video to your friends so that they can also learn. Thank you and see you in our next class.